Hello guys, welcome back to my channel. For today's video, I'll be discussing to you about quadratic equation in standard form. Let us be guided with the following objectives. First, describe quadratic equation and write quadratic equation in standard form. Now, what is a quadratic equation? Quadratic equation in one variable is a mathematical sentence of degree 2. So meaning to say that the highest exponent is only 2. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. In the equation ax squared plus bx plus c equals 0, ax squared is the quadratic term, bx is the linear term, and c is the constant term. Example of quadratic equation written in standard form is 4x squared plus 8x minus 3 equals 0. If you have observed, the terms on the left side of the equation are being arranged starting with the second degree term, followed by the first degree term, and the constant term. And on the right side of the equation, we have here 0. So this is the standard form of a quadratic equation. So with this standard form of a quadratic equation, the quadratic term is 4x squared, the linear term is 8x, and the constant term is negative 3. In the quadratic equation 4x squared plus 8x minus 3 equals 0, the value of a is equal to 4, the value of b is equal to 8, and the value of c is equal to negative 3. By the way, where did we get the value of a equals 4? We get this one from the numerical coefficient of the quadratic term, which is 4. And we get also the value of b from the numerical coefficient of the linear term, and the value of c is coming from the constant term. Now we are going to write the quadratic equation x times quantity of x minus 2 equals 5 in standard form, and we're going to determine the values of a, b, and c. Okay, for our solution, we have here, we are going to apply the distributive property of multiplication. So, the given equation is x times the quantity of x minus 2 equals 5. By applying the distributive property of multiplication, we have to multiply x times x. And then after that, we have to multiply also x by 2. Okay, just copy the minus sign. And you copy 5. So, x times x is x squared. Why we have x squared? Of course, you are going to add the exponent. And here, the exponent of x is 1. The exponent also of x here is 1. So, x 1 plus 1, we have 2. We are going to add the exponent of the variable x. Then we have to multiply negative x times 2, so we have negative 2x. And then you copy 5. Remember that our main target is standard form, wherein the right side of the equation is equal to 0. So, but here we still have 5. So what are we going to do is, we're going to apply the subtraction property of equality, wherein we're going to subtract both sides of the equation by 5. Or you used to have it as transpose 5 to the other side of the equation, but the original for that is you're going to subtract 5 both sides of the equation. So once 5 will be subtracted by 5, it will become 0. And on the Left side of the equation, this will become x squared minus 2x minus 5. So if you have observed, we are now in the standard form of the quadratic equation. So since it's already in the standard form, we can now easily determine the values of a, b, and c. So we have here a equals 1. Where did we get 1? Coming from the numerical coefficient of the quadratic term. If you have observed, there is no 1 here, but if the numerical coefficient is only 1, no need to write 1 here, but it's already understood that there is 1 as our numerical coefficient. Next, to get the value of b, that is coming from the numerical coefficient of the linear term. And for the value of c, which is the constant term, we have here negative 5. Now moving on with the second example. Write the quadratic equation quantity of s plus 3 squared plus 4 equals 4s plus 3 in standard form, and again determine the values of a, b, and c. Now for our solution, we have here the given equation. Quantity of s plus 3 squared plus 4 equals 4s plus 3. If we have observed, we have here a square of a binomial. So we are going to get the product of the square of the binomial first. To determine the product of the square of the binomial, the first term is equal to the square of a binomial. So s is the first term of a binomial, and 3 is the second term of this binomial. So again, to get the first term, because the resulting product for the square of a binomial is a perfect square trinomial. So meaning to say, we are expecting to have 3 terms once we're going to get the product of a square of this binomial. So again, the first term is the square of the first term, which is s, and the second term is equal to twice, that's why we have here 2, twice the product of the first term, which is s, and the second term, which is 3. That's why we have 2 times s times 3. And the third term is equal to the square of the second term. That's why we have here 3 squared. Again, to get this product of the square of the binomial, the first term is equal to the square of the first term. The second term is equal to twice the product of the first term in the second term. And the third term is equal to the square of the second term of a binomial. Now you are going to copy the remaining terms. We have plus 4 equals 4s plus 3. Then after that, of course, we are going to simplify further. We have to copy s squared, then 2s times 3, or 2 times s times 3, we have 6s, and 3 squared is equal to 9, because 3 times 3 is equal to 9, not 3 times 2. Then we copy 4, and then we have to copy the remaining terms on the right side of the equation for s plus 3. Then we're going to combine like terms, so we can combine 9 and 4. So you copy s squared plus 6s, and then 9 plus 4 is 13. Now, we have here 4s plus 3 on the right side of the equation. Remember that our main target is the right side of the equation will be equated to 0. So what are we going to do in order that the right side of the equation will become 0? We are going to apply the properties of equality, and one of the properties that we're going to use is subtraction property of equality, wherein we're going to subtract both sides of the equation by 4s plus 3. So once we're going to subtract this one by 4s plus 3, the right side will become 0, And on the left side, we have negative 4s and negative 3. Or if you find it difficult to remember, you just try to recall about the transposition that this 4s plus 3 will be transposed to the other side. So this is positive. So once transposed to the other side of the equation, it becomes negative 4s. And this positive 3 transposed to the other side becomes negative 3. So the right side of the equation now becomes 0. Okay? And after that, we are going to combine the terms that are similar. So s squared, there is no other s squared, so we have to copy s squared. 6s, we also have here negative 4s, so we can combine 6s and negative 4s. And the answer for that is 2s. Then lastly, we have 13 and negative 3. So 13 and negative 3, the answer is positive 10. So we have now a standard equation, s squared plus 2s plus 10 equals 0. Okay, since the equation that we have is already in standard form, we can now easily determine the values of a, b, and c. So the value of a is equal to 1. Where did we get 1? That is coming from the numerical coefficient of s squared. Though you are not able to see 1 here, but it's already understood that there is 1 as the numerical coefficient. Okay? Now, for the value of b, we have 2. Where did we get 2? That is coming from the numerical coefficient of the linear term. And for the value of c equals 10, that is coming from the constant term, which is 10. Now, let's have the third example. Write the quadratic equation quantity of a plus 1 times the quantity of a plus 2 equals 3 in standard form, and again determine the values of a, b, and c. Okay, for our solution, we're going to use the FOIL method. F stands for the first term, O stands for the outer terms, I stands for the inner terms, and L stands for the last terms. Actually, this is also called the smiley face method because once we're going to connect the first terms, the outer terms, inner term, and last term, it seems that we can form a smiley face. So let's try to see that one later on. So the first terms are A and A. So we have A and A. Our outer terms are A times 2. Our inner term is 1 times A. And the last terms are 1 times 2. So it seems that we were able to form the smiley face. That's why it's called a smiley face method. Hopefully you are all smiling. Now, multiply. So the a times a, the answer is a squared. So again, we have to add the exponent of a, and we have here 1 and 1. So we have 2. Then a times 2, the answer is 2a, not a2. And 1 times a, the answer is a. Do not write any more 1 because it's already understood that we have here 1 as our numerical coefficient. And 1 times 2 is equal to 2. And you copy 3 on the right side of the equation. Now, what's the next? We are going to transpose 3 to the other side of the equation in order that our right side will become 0. But actually, that is coming from subtraction property of equality. I will just use the word transpose. Okay, so we have a squared, you copy. And why we have 3a here? We have combined 2a and a. 2a plus a, we have 3a. Then you copy 2. So positive 3 becomes negative 3 once transposed to the other side of the equation. So the resulting equation now is a squared plus 3a plus 2 minus 3 equals 0. We can still combine 2 and negative 3. So the resulting equation now is a squared plus 3a and 2 minus 3 is negative 1 equals 0. So this is now the equation in standard form. Since the equation is already in standard form, we can now determine the values of a, b, and c. So the value of a is 1, coming from the numerical coefficient of the quadratic term. The value of b is equal to 3, coming from the numerical coefficient of the linear term. And the value of c is equal to negative 1, coming from the value of the constant term. Now, moving on with our example number 4. Write the quadratic equation quantity of 3x plus 4 times quantity of 3x minus 5 equals 4x plus 3, and determine the values of a, b, and c. For our solution, we are going to use again the FOIL method. So we have to multiply first terms 3x times 4x. And then we have the outer terms 3x times negative 5. And then the inner terms, we have 4 times 4x. And for the last terms, we have 4 times negative 5. So we have now somewhat like a smiley face. Then copy the remaining terms on the right side of the equation, 4x plus 3. So now we are going to multiply 3x times 4x, and of course the answer for that is 12x squared. Then 3x times negative 5, the answer is negative 15x. 4x multiplied by 4, the answer is 16x. And 4 times negative 5, the answer is negative 20. You copy 4x plus 3 on the right side of the equation. So now we are going to equate the right side of the equation by 0. But how? Of course, we'll just apply the transposition method, but the original for that is applying the properties of equality. So we have 12x squared. You copy negative 15x plus 16x. The answer for this is x only. And you copy negative 20. So 4 positive 4x becomes negative 4x, transpose to the other side of the equation, and 3 becomes negative 3. So the right side now is 0. Then let's try to check if there are terms that we can still combine. So 12x squared, no more other term with x squared, so you copy 12x squared. Then x and negative 4x, we can combine this. So the answer for that is negative 3x. Lastly, we have negative 20 and negative 3. And the answer for that is negative 23. So if you have observed, we have now a quadratic equation in standard form. Since the equation is already in standard form, we can now easily determine the values of a, b, and c. So the value of a is 12. Where did we get 12? Numerical coefficient of the quadratic term. The value of b is negative 3, coming from the numerical coefficient of the linear term. And of course, the value of c is equal to negative 23, coming from the constant term. Okay, hopefully that you learned something from our video for today. Remember, my dear students, that life is sometimes like an equation. Many see it as full of complication, but always remember, every equation has a solution. All less problems have an exact solution. Thank you for watching, guys. See you next time. God bless you all. Thank you.